Okay, let's move on and talk about network mapping using Traceroute. The Traceroute capabilities of NMAP are similar to those available using the Unix command line tool of the same name. In both implementations, Traceroute sends specially crafted packets over a network in an attempt to discover the network path between two systems. The advantages of using NMAP are that the functionality is built directly into NMAP and that its probing is performed in reverse order. Here we have two geographically separate systems, our testing system in Phoenix and the target in Tampa. Using Traceroute, we can discover the intervening network topology, which might look like this. In this simple example, Traceroute has identified 3 routers and 2 networks that were previously hidden from us. We of course already knew about the local and remote networks. Traceroute works by manipulating the time to live field in the IP header. The time to live, or hop count, is a mechanism that limits the lifespan of a packet and prevents data from remaining on a network indefinitely. When a packet is built and sent onto the network, the sending system sets the time to live to some finite value. For this simplistic analysis, we've set the time to live to 3. In any real network, the time to live would default to a more realistic value, perhaps 64. Routing rules require that each router decrement the time to live value before passing the packet on, and that when a packet with a hop count of 0 or 1 is encountered, it must be discarded and the originating system be notified using an ICMP time exceeded message. The Unix traceroute command starts with a time to live of 1 and increments the value with each successive packet. NMAP's traceroute is unique in that it starts with a large time to live and decrements the value down to 1. By working down through appropriate time to live values, NMAP can employ clever caching algorithms to speed up a trace and send fewer packets. Like standard traceroute, NMAP can use ICMP, UDP, or TCP probes, but the choice of which type is used is dependent on the type of scan being performed and is not directly user selectable. Traceroute is enabled using the --traceroute option. In this command, we've also specified that we only want to scan port 80, and the -n option turns off DNS name resolution. From the output, we can see that NMAP performs the host enumeration phase and tells us that the target system is up or live. Then it moves on and performs the port scan phase and prints the output telling us that port 80 is closed. After completing the port scan, it performs the traceroute phase, in this case using TCP port 80. The output shows us the discovered list of routers to the target system. The hop column displays the time to live, the RTT column lists the round trip time for the packet in milliseconds, and the address is of course the IP address of the router. The ellipsis at hop 3 indicates that no response was received from the probes with that time to live value. In this module, we've presented the host enumeration and network mapping phases of NMAP's operation. Using these 2 phases, the network security tester can discover the topology of the networks under review and identify live systems on those networks.